Hi everyone. In this video I will walk you through the finite element modeling of a truss structure as shown here. So a truss structure consists of 3 or more bar elements. A bar element is one-dimensional and has 1 degree of freedom and can carry only axial loads. A truss structure is 2-dimensional and has 2 degrees of freedom and can also carry axial loads. So we have this information. The material is the same for diagonal and horizontal members of this structure, but the cross-sectional area is different. The diagonal members are thinner. So we're going to input this information into the model. So let's start the modeling in Abaqus. Okay, I will start again with this standard explicit model. I would set the work directory where I want to save my file. Now I would rename the model here. Okay. Today, instead of using this module section, I'm going to use this model tree. So double click on parts. Truss, 2D planar, deformable wire, and the approximate size 20 is good. Continue. Now I would enter the starting point, the coordinates of the starting point here, 0, 0, enter, 8, 0, enter. Now click on this AutoFit view, and you can scroll down or scroll up to zoom in or zoom out. Now you can continue sketching the geometry. Press escape, click done. Next we need to enter the material information. Double click on material, mechanical elasticity elastic, Young modulus is 36 E6, Poisson's ratio is 0.3, click OK. Now it's time to create sections. As we have diagonal and horizontal members, we need to create 2 sections. Double click on section, this one should be diagonal, beam, truss, continue. Cross-sectional area is 0.02. Okay. Now if you expand this section, you can see we have diagonal here. Repeat this for horizontal. Continue. Cross-sectional is 0.045. Okay. And now we have these 2 sections. It's time to assign the sections. Now press and hold the Shift key and select these horizontal members. Done. Select horizontal. Okay. Now draw a rectangle about these diagonal members. Click on done and select diagonal section. Okay. Now I would expand this part section. If you double click on mesh, you can start meshing the structure. So I would click on this assign element type. Now I would select the entire structure, click OK, click done. Here select truss, and again we have this truss 2-dimensional 2-node elements, which is assigned to all the members of this structure. Click OK. Now see edges. Again, select the entire structure. Done. Use the method, set the method to by number, and type 1 here. Apply. OK. Now click on Mesh Part and answer yes. Now it's time to create an instance of the part that we already created. Expand Assembly in the model tree, double click on Instances, Parts, Truss, click OK. In Abaqus, you can create many parts and then assemble them together to form a model. You can also create many instances of one part. For example, in a bridge, you don't have to create every girder. You can draw one girder and then create several instances of that girder. Now it's time to create boundary conditions. And before doing so, we need to understand how are the degrees of freedom numbered. So number 1, 2, and 3 show the translational displacement along x-axis, y-axis, and z-axis. And number 4, 5, and 6 show the rotational displacement about these axes. We have a pinch support at the left end and a roller support at the right end. So now I would expand this model tree, expand steps, initial, double click on boundary conditions. For the name, type pinch support. Category is mechanical, type is symmetry, anti-symmetry, and caster, continue. Now the prompt area asks you to select the region that you want to apply the boundary condition. Select this endpoint here, done, pinned. OK. Now it is added under boundary condition section. Add the roller support, double click on boundary condition. Type roller support, mechanical, symmetry, anti-symmetry, and caster, continue. Select the right endpoint, done, and select this X asymmetric. Click OK, and the boundary conditions are now applied. Now let's take a look at the loads. We have 1 horizontal load and 3 vertical loads. Before I enter the loads, I need to create another step that starts after the initial step. So I would double click on steps. For the name, I would type apply loads. It would insert this new step after initial. It would be general, static general, continue. You can add a description here. Make sure nonlinear geometry is off. Click OK. Notice that this new step is added under the steps section. Expand this here and double click on loads. Now you're ready to enter the loads. So the first one is the horizontal 15 kilonewtons. Category is mechanical, concentrated force, continue. I would select this point here, done. And as it is in X direction, I would add 15 here. Click OK. So here I have one load applied onto my model. All the 4 loads are entered here. If you right click on any of them, you can edit. So as you see, I put a negative sign here because they are in negative Y direction, these vertical loads. Click OK. Now we have these loads applied to the model. Now we can create the job and submit it and see the solution. So on the model tree, double click on jobs. For the name, type Truss problem. The truss part is selected as the model by default. Continue. click OK, Job Manager, and submit the job. In the bottom window, you can see that the job has been completed successfully, so it shows that there is no error and it has been executed properly. Now you can see the results from this tab, or you can close this dialog box and go to Visualization, go to File, Open, Truss Problem Output Database, click OK, select it and click OK, and now you are in the Visualization module. Click on Plot Deformed Shape, plot contours on deformed shape, and you can see how the truss structure deforms under these four loads. From Options tab, go to Common, and here select Labels. Put a check mark next to Show Element Labels and Show Node Labels. You can change the color if you want. And then apply. Now you have these red colors for the members and these yellow colors for nodes. Close this dialog box. So we have 15 elements and 9 nodes. The numbering might be different for you. So now you can go to Results, Field Output, select Spatial Displacement and select U2. Apply, OK, and this time you have the legend for displacement in Y direction, and all the members are color-coded. You can change the font size for the legend if you want. If you go to Viewport tab, select Viewport Annotation Options, and then select Legend, Set Font, and here you can modify the font size. Now you can close this dialog box. Suppose we want to create a text file that contains the information of reaction forces and nodal displacement. So you can go to this Report tab, Field Output. For position, make sure to select Unique Nodal, and then expand reaction force, select reaction force in X direction, in Y direction, expand spatial displacement in X direction, Y direction, and then open Setup tab. Click on Select. The report file is by default selected. You can change the name, type Truss Problem, click OK, and now apply. Now close this dialog box. If you return to the folder, you can find the report file here. I would open it with Word. So we have displacement in Y direction, displacement in X direction, reaction force in X direction and in Y direction for each of the nodes and elements. We also have minimum and maximum amounts of these loads and displacements here.